Okay, so I think we're gonna get started, and hopefully David will soon join. So, hey everyone, welcome to another protocol meeting. I'm filling in for Justin today, emceeing this. So, in these meetings, we discuss potential protocol changes. These changes are outlined in these documents called CAPs, Core Advancement Proposals. And the big change we're working on right now is Project Jump Cannon, which is a feature to introduce native smart contracts on Stellar. So we've divided this massive change into a set of composable caps. And the agenda specifically for today is we're going to talk about Cap 53, smart contract data. This was recently published by Graydon. We're going to talk about Cap 52, smart contract interactions, minimal, which was recently introduced by John. And we're going to talk about the smart contract lifecycle, Cap 47, which was recently updated by Siddharth and requires some further discussion. So let's do this. Graydon, can you kick this off with a review of Cap 53?
Yeah, just give me 1 second.
Okay.
Got it. Yeah. Sorry, I had the pull request open, and then I actually wanted to switch over to the merged version of it. So this is a fairly straightforward cap. It's not really introducing anything that probably will be a surprise to anyone here. It's just formalizing something that was left out or left sort of for future caps in the modularization that we've been doing, splitting off conversation into separate pieces so that we can work on them separately and land them separately. But it's fairly tightly related to the data model that was presented in CAP 46. So a lot of the motives in CAP 46 around the data model implicitly talked about how that data would be stored permanently. So there's concerns that bear on the data model that are sort of interacting with it while it's in memory, and then there are concerns more related to its long-lived accessibility over multiple invocations of a smart contract while it's stored on the blockchain. So some of the requirements that are sort of rephrased and brought into the foreground here have to do with interoperability, where we want there to be something a little bit more general, or I should say, less general, more interoperable, more generally understood, more widely understood structure to the data than just a byte buffer. A lot of smart contract platforms essentially only provide a byte buffer storage service to smart contracts, which means that nobody really except that exact version of the smart contract code can necessarily read any of the data that's stored there, and that produces interoperability problems if other third parties want to access it offline, browsers that want to take a look at the data. It also creates versioning problems because it means that you're rigidly locked to the schema language or serialization format that the contract used. It means that if a contract wants to pass data, it has to, from one contract to another, it has to transform it. So there's a whole interoperability angle here, which we wanted to address in the CAP46 data model, and we're carrying that forward here. And I think a lot of the concerns only make sense when considered in terms of persistent data, but this is the persistent data cap. So here we're just talking about basically what the ledger entries is going to store things looks like, and a handful of host functions for accessing it. They're very basic functions. They're just key value store access functions. They're point access functions. They're not range functions. They don't include iterators or range queries or anything like that. They're just get, put, do we have a key, and delete the key. Very simple host functions. The interesting thing really is the choice of granularity, which is left to the user. So this is a little bit different in that many blockchains provide a this is different than many smart contract systems you'll see. Many smart contract systems provide a key value store, which is keyed by a byte string, some kind of a prefix that goes into a Merkle tree or something like that. We do not have we essentially don't expose any interior nodes of the Merkleized storage that we use to users anyway. We just provide a single bucket list hash. So the fact that our data structure has internal Merkleization doesn't really apply here anyway. And structurally, it wouldn't make sense. But um, what we're doing here is also allowing structured values as keys rather than byte string. So of course, you know, you can serialize any value, and you will in the case of using it as a string here. But the API is encouraging users to have fairly structured values so they can have fairly rich keys. And implicit to all of this is that there's a parallel access and consistency model that's discussed in this cap, which is that we're trying to encourage the possibility of executing smart contracts in parallel. And if you have parallel access to a data store, you have to talk about what the consistency model is. What does it mean when two different users access that model in parallel? So we're specifying here that it's a strict serializability consistency model, which is the strongest possible. It's you know, equivalent to the exact order that the transaction sets specified the transactions executing in. That has to be the observable side effect model. And parallel models, parallel consistency models imply the existence of some kind of a concurrency control mechanism, how you actually enforce that. And in this cap, we're talking a little bit about a very strong mechanism for concurrency control. It's what's typically called deterministic scheduling or non-conflicting concurrency control. The idea is that every transaction that enters the system will pre-declare a footprint. So there's this thing called a footprint, which is the set of keys that a transaction is going to touch, whether it's going to read them or write them. It actually marks whether it reads or writes each key in its footprint. And the footprint is static information that accompanies a transaction. So this cap doesn't describe exactly how a footprint is encoded or accompanies a transaction invocation, because we don't even have a cap open right now that has transaction invocation, or at least we haven't settled on one. We have several caps open right now. But when transaction invocation occurs, it's going to need to provide a footprint. In this cap is asking that footprints are available, and that the footprint defines the keys that are that the transaction is allowed to perform these data access operations on. So if you try to perform a get against something that's not in your footprint, the get will fail. Even if the value is there, if it's not in the transaction's implicit footprint, it's defined as failing. Similarly, for a put or even a has, point query, anything like that, you have to have it in the footprint. So for simple transactions, this is fairly straightforward. You can tell what they're going to read or write, and so you just put things in the footprint that they're going to read or write, and that's fine. For complicated transactions that have a highly dynamic behavior, maybe it's not even clear what they're going to read or write because it's you know, subsequent to a transaction. It's determined by an earlier read in the transaction. These are what are called transactions with dynamic footprints. The recommendation in this cap and what we're prototyping is a fairly standard technique from the literature, which is often called reconnaissance queries. I think I'm using them here. I'm using the term footprint recording here, which is that you just run the transaction offline before you submit it on a read snapshot, and that gives you a fairly good guess, an approximate footprint that you can then staple to the real transaction when you submit it, and it will succeed if that footprint still matches. So it essentially pushes concurrency control out of the transaction processing loop and into the user's lap. And so the user is now racing on divergence between read snapshots that they use to construct their footprint and the footprint that they actually submit a transaction with. And so theoretically, if there's a very, very highly contended key and it's a very dynamic query, they may have to retry multiple times, because if there's any significant divergence between the recorded footprint and the footprint they submit, their transaction could fail, but the database itself doesn't have to actually perform the concurrency control. So in some ways, this is shedding load from a concurrency control mechanism inside of a database out to the users. And that has turned out to work very well for maintaining a very even high throughput on existing databases that adopt this technique. So we're trying to adopt that technique as well. So those are the two sort of main topics in here. The fact that that the user has control over granularity. I should go back and talk a little bit more about granularity just for a second, which is that the granularity control that exists here has a natural tension in it. So doing a point read on a key value store necessarily has some overhead. It has data framing overhead. It has serialization overhead. It involves going to the I/O system at all. It involves touching the disk, doing a seek, doing a read. All of that overhead is um, potentially quite high. And so it can be worth trying to amortize that overhead and read more than one item if you are going to access more than one item. You don't necessarily want to pay that on a bit by bit or byte by byte basis. You want to bring in a bunch of bytes at a time when you do an I/O. And so that amortization tension pushes you towards larger I/Os in a larger granularity of storage. But then the flip side of that, of course, is that if you read or write data that you don't actually need, if it's wasted and you actually only wanted to change one byte in the middle of a large data structure, that's waste, and you're paying for that waste in terms of fees or CPU time or I/O or whatever. And so that pushes you in the opposite direction of having fine-grained uh, data, and that problem actually just magnifies itself when you start talking about parallelism, because again, your footprint is a unit of contention. And so if two transactions contend on the same data value, they can't execute in parallel. Basically, that's what the footprint is doing, is that it's giving a static scheduler the opportunity to partition execution into separate lanes, and then those lanes will run with no coordination. But those lanes necessarily are serial themselves. You only get parallelism between them. And so if you have a whole lot of transactions, for example, that all touch some common data value in their footprint, they will all be scheduled to run in serial. And so to exploit parallelism, it is in the favor of the user to have finer grained footprints. So you have this sort of two different directions of pressure. It's a natural trade-off between fine-grained and coarse-grained data access. And so we don't specify what the granularity is here. We try to be very open about that. And so that's why the key type is literally just an arbitrary value. I think that's all I really had to say about that. There's not a lot in this cap. It's actually quite small, and it kind of just does exactly what you expect as a key value type.
Awesome. Can you just quickly talk about the rationale for why there is point access only?
Yeah, so range queries essentially aren't compatible with static footprints because we don't know how far they go. That's the simple version. We could theoretically, but we would lose the parallelism. So
Yeah. Awesome. So we are kind of like actively trying to deter contract developers from creating these like creating like a need for range queries with some, like for example, like a classic order book is probably like not a great fit for this, which is okay with us.
yeah, and I mean, it's a good point, which is that in a broader sense, a static footprint actually bounds the I/O you're going to do. It allows us. I mentioned this in the contract. It allows us to essentially have no surprises. The contract is not going to be interrupted in the middle of the contract in order to actually go touch the disk dynamically. Everything that it's going to read, it says up front, and therefore we can just do a bulk read at the beginning of the contract. In fact, we'll integrate into a single pass through the storage system all of the reads from all of the contracts in a given parallel execution lane. We'll just read all their data at once at the beginning of a transaction set execution, and then write it back at the end. So that kind of thing is naturally incompatible with something like dynamic range queries. But that said, because you can store arbitrary values, if you want to store a map, that's completely reasonable. One of the values that you store, it doesn't have to be just a small string or a number or something. You can store a map that has a bunch of stuff in it and then do a range query on that map. It's just that when you do an IO, you're going to get the entire map is going to come off the disk. So you have to sort of navigate that trade-off yourself, maybe shard your map into a bunch of different submaps or something like that if you're interested in not loading and storing the whole thing every time.
When I tried to use a very early version of this design, I don't know, like a month ago or something, one of the kind of like annoyances that I quickly encountered was like when I wanted to, partition my namespace, I basically was like, okay, well, I need some kind of key that is a tuple. And so I just used like the seval vec option, and I just like pumped a vec full of stuff and then used it as my key. That's how I got like a partitioned namespace. The thing was like doing that seemed like kind of inefficient because it's like, okay, like I need a three, like, a three tuple as my key. So I like I create a vector, host function, I push into it, host function, I push into it again, host function, I push into it again, host function. And then I call the like, get function, host function again. And it just seems like a ton of work to get a single piece of data. So do you have any thoughts about that?
Offhand, I guess I'm not sure that it is a ton of work. It would be my first reaction in the sense that um, I don't know. So for example, we could make a contract put one, contract put two, contract put three that takes three values as inputs, three keys, four keys, five keys. We could reflect those usage patterns in function signatures as conveniences, but I'm not sure they would do any less work. And I don't think the calls in and out of the VM are actually all that expensive. I think you're only talking about one extra opcode and a couple of a push and a call. So from a user perspective, I think you have a good point. And I think if the SDK can't make that pattern fairly convenient in terms of putting sort of superficial porcelain on top of it that makes it look nice, then perhaps we should expand the functional repertoire to provide additional support for that.
I think
But
one thing we might be able to do, just responding to your comment about the SDK, is make it easy to use things like tuples. Like we're
exactly.
trying to make it easier to use things like vecs already, and maps. Tuples might be one thing we could add.
Yeah, that's kind of what I'm expecting is that you can do the kind of thing that I hate to use this as precedent, but the Rust standard library does something similar here, where it just says people use tuples up to about 5 or 7 or 12 or whatever. So like just macro generate enough support for all the basic tuple types anyone's likely to use, and just have them as conveniences, and then you only wind up having to use this arbitrary vector sort of approach if you're doing something weird.
Yeah, I mean, as long as the cost of doing all the host functions isn't particularly high, then it doesn't really matter to me because you could always put SDK support to do this. Indeed, I just built my own thing that like I could pass the functions to and the parameters to, and it would shoot a vec back out at me, so it would look a lot less disgusting. We could generalize that, of course, as long as the cost isn't high at the protocol level. So
I think so. I think the cost of a function call is fairly small, host function call. And again, absolutely, it's the case that if we measure this and it's miserable. I mean, the other thing is that I don't honestly think there's masses of IO operations in the normal contract path, right? I think you're only talking about a couple of point accesses per contract call anyway. So I'm not super concerned about that path. But if we measure it, it turns out to be expensive, we can absolutely revisit this and try to add fast paths or optimized versions for this.
Great. And do you think there could be contracts that will be vulnerable to moving footprints? So you mentioned about the situation where dynamic footprints is an inconvenience, or you have to do reconnaissance queries and they potentially could be out of date. But I'm wondering if there's an angle here where that actually makes a contract vulnerable in the sense that one participant of that contract could prevent another participant from interacting with it.
Yes, absolutely. This is, as far as I can tell, this is basically always the case with concurrency control. If you have any kind of concurrency control mechanism somewhere, you can create a starvation. You can starve one party by just hammering on a contended resource. Um, in this particular case, the contract developer has a fair amount of control over it because they can change the granularity. So if the contract developer feels that this is a risk or sees this happening or something like that, um, they can re-architect the contract to essentially sacrifice concurrency, um, to get rid of the ability to have that kind of concern. So at the extreme end, your footprint is the contract data. There's only one contract data. Everyone who talks to this contract always accesses the exact same contract data, and that means that everyone knows exactly what their footprint should be. It's always just the contract data. There's only one element. Um, Everyone specifies the same thing, and they all get serialized. And so there's no you can never have to have your footprint invalidated because your footprint is always correct. So you can do that if you find that's happening. It's just the worst case, right? So you move away from that if you want more concurrency. But if you're seeing that people are um, able to and actively exploiting, some kind of starvation, concurrency starvation situation, then you may have to move back towards that. And I don't I don't personally know a way to avoid that. I think if we did any kind of dynamic locking, we would be in exactly the same situation where someone could just flood the system with transactions that take a lock and deny anyone else the ability to make progress. And we would be in a worse situation because dynamic concurrency. The thing that's really good about static concurrency control as an approach is that you have a guaranteed sort of throughput, that the things that you have scheduled um, will complete one way or the other within their allotted time slice, right? They will either finish or they will abort. And so your abort rates go up, but the system continues to run in this particular strategy. The other strategy would be more like, we would give people the ability to drag the entire system down. So a transaction set would potentially slow down dramatically because people are contending on a hot resource. So it's there aren't a lot of free lunches in concurrency control, and I kind of feel like that's a natural trade-off here. Does that answer the question? I know it's not like a fun answer.
No, yeah, I think that makes a lot of sense. The fact that the proposal really gives the contract developer a lot of control, and doesn't define the level of granularity that they have to use, I like. Yeah, it's good.
The other question?
To say with this, so
Well, great. It looks like you've created one of the least contentious caps that has ever um, came to life. Thanks for that.
hooray!
Um, cool. So let's dial up on the contentious or the contention levels. John, I think this is probably the third iteration of smart contract interactions.
Sure. So for those of you who were here at last week's meeting, you might recall that we had a pretty big debate about this. And I was, in the interest of actually agreeing on something, I decided to just remove all the functionality from the proposal, which sounds a little backwards, but in the context of smart contracts, you can kind of push all of these authorization questions down to contracts and let them do everything themselves. And we had been kind of moving in that direction on cap 50 anyway, with the introduction of like the invoker signature none option and stuff like that. So basically, at a high level of what's in this proposal, there is just like in the old proposal, there is a new a new transaction type and a corresponding envelope type called invoke contract transaction or invoke contract transaction envelope. And this contains the normal stuff like before, source account, sequence number, fee. It contains the contract that you're invoking, the ID, the parameter, the symbol, the parameters. It contains the read write set that you would need for cap 53, as Graydon was just talking about. And then that's pretty much it. So how does one actually use this? There are some examples in the cap which are pretty instructive about what the universe would look like if we actually did this. There's like a whole example section where I hacked up like 2 versions of an ERC20 type contract, but they look quite different from your normal ERC20 because there's not really like a reliable message.sender that you can use in this context. But basically, the only other thing that's here is just a few host functions that are useful for actually doing some of the things that we discussed last week. So there's some access to thresholds from accounts. There's access to getting the signer weight by account key by signer key. The signer weight for an account by signer key, kind of hard to say. I added a verify ED25519 function, which I think is also in cap 51, which was being written at the same time. And that's pretty much it. So any questions about this?
So I'm just trying to get into this. Can you talk a bit about like the implications around like accounts and we were talking about this a bit last week. Like what does this mean for like, classic multi-sig accounts on the smart side?
The beauty of it is that the proposal means basically nothing for those things because the contracts get to make their own decisions. So for some context, like if we scroll down almost all the way to the bottom, the last example is like a simple token based on account signatures. And this builds on the classic Stellar multisig mechanism. Basically works exactly the same with 2 exceptions. No pre-signed transactions here. Sorry, no pre-auth transactions and no #X signers. But it works exactly the same and it works at medium threshold and everything kind of is exactly what you would expect. But right above that, there's another example that uses the single key version that I was proposing as the invoker signature last week. And so this framework basically lets contracts build whatever they want. If you want some kind of support for Stellar multisig, that'll really be up to contract developers and ecosystem standards and stuff like that. My intuition is that those things won't really materialize because they're not efficient structures on the blockchain, but they might materialize from case to case.
Something that immediately jumps out at me with these examples is that it may be difficult to write these functions. Some of these, so I'm looking at the simple token based on account signatures example you were just referencing, and the second code block has a check function. It says internal function. Is that something that the network is providing, or that's an internal function that the contract provides?
That's a contract function that's not exported.
Got it. So I can imagine. So I've had to write code like this for our SDKs when we were implementing SEP10, and I think it was SEP10. And one thing that is quite difficult to get right is iterating over a set of signatures for a message and determining a set of weights, because there's different things you have to do. Like you have to make sure that you don't, if somebody includes the same signature twice, you don't use it twice to get double the weight, different things like that. So do you think by going this approach, expecting people to implement their own authorization, we're increasing the chance of foot guns where people are going to implement what they think is Stellar multi-sig signature authorization verification, but it doesn't actually exactly line up with it?
That's definitely possible. I mean, my kind of ideal universe here, in the sense of what I hope people would do, is probably somebody would deploy one contract that has a unified key structure, a unified signer scheme, basically. You pass it some kind of opaque blob. The beginning of the opaque blob is a discriminant saying hey, what kind of signature is this? Is it a single key ED25519? Is it a single key ECDSA? Is it like a stellar multisig? Is it some other scheme that I'm not thinking of, like some kind of like quantum resistance scheme? Who cares? And basically, like the entire ecosystem relies on this contract. Or sorry, another example would be like, I know Lee, you had requested like aliases. We could have like a single ED25519 aliased version. All of that implemented in one contract that everybody kind of relies on as an ecosystem standard. You don't have to rely on it, but if you do, you kind of get compatibility across the entire universe for free. That's what I would hope would happen instead of everybody rolling their own. But like, yes, at the very worst case, everybody rolls their own. And if you don't know how to roll your own, for example, like I didn't account for the repeated keys in this example, working too fast, you can get yourself in trouble. And just to follow up on that, part of why I'm a big proponent of single key signatures and doing everything else as like, secure multi-party communication computation is because there's a lot less ways to blow yourself up on chain. A single signature is easy to verify. In fact, my argument would generally be that if you want to write a good contract that is really safe and easy to audit, you should use the simplest authorization scheme possible, which is that.
Can I ask a follow-up question? Is that I'm a little bit, well, I'll be honest, I'm a little bit behind on this entire aspect of the interaction. If you're dealing with a case where people do use the simplest and safest approach, but suppose you're a smart contract author who's trying to be conservative and you don't want to do anything too elaborate, and you're using this interface. Am I correct in reading this that you're probably not going to have to include an awful lot of code in your contract to make this work right? Is that correct? That the sort of the number of calls that you have to make to host functions is not particularly huge.
You're talking about in the case of like a single ED25519, right?
That's right.
Yeah, in that case, like it's very, very simple. That example is in the first one. And like the code is basically like check the nonce, hash your message, do a ED25519 post function call. That's pretty much it. And everything just traps if the wrong thing happens. And you could probably write this in like 5 lines, 3 host function calls or 4 host function calls. Pretty lightweight, all told. And it's pretty hard to escape all of like some of these parts no matter what you do. Like at some point, if you're going to do the authorization on chain, you probably need to do at least one ED25519 signature verification or ECDSA signature verification. So it probably could be like a little lighter than this, but probably not significantly lighter than this.
Well, I guess this I'm just being my typical trying to shave things down approach. This feels to me like even the minimal version is a blob of code that will have to get stapled onto every single smart contract, and they will all run. Even if they all wind up being conservative and they all take your advice and be conservative, this is all in VM rather than extra VM. There's no way for them to say, fast path me, just do this conservative thing.
So yes and no, because like even though I think that everybody will be conservative, I still think the ideal universe of everybody being conservative is them all using a single, contract that implements this all, so that you don't end up with the same code cloned everywhere. You just have a cross-contract call. You probably think that's worse than it is from a performance perspective, but it doesn't end up with like 10,000 or 1,000,000 copies of the same code everywhere on the blockchain. So that's the plus. The second part of it though is that if there is a lot of ecosystem adoption around some kind of standardized signature verifier, we could always deploy a native version of that that's super fast.
I see. So you are.
But I'm not.
Okay.
I want to make sure I'm not promising you that that's ever going to happen.
No. I'm not hearing you as a promise. I'm just trying to understand what level of code reuse you're assuming is going to work, and also, so calling a third party to do your authentication for you definitely gets us into the question that is the other thing we're going to be discussing today, which is mutability of contracts and versioning of dependencies. Like I think if there's anything someone is going to not want to trust to a third party, it's the authentication path. unless they're 100% sure that that third party is, you know, immutable, and like the code that they audited the last time they read it.
I think another option is, it could be a cross contract call to this one contract that's living in one place. So we're talking about reduced WASM size. It could also just be the library code that everybody's sharing. So people
Right,
aren't necessarily.
there is no mechanism for library sharing besides stapling this, like including the code into the contract.
Yeah. So obviously there's no space saving. Like all these contracts are going to have the same code within them, but addressing the concern of people implementing these things correctly, if everyone's using this common piece of library code that has either been audited or people generally have more trust in, then they don't really, you don't really have to worry so much about the mutability concern because they're choosing to build that into their contract at build time.
There are some trade-offs there. Like, I think it would generally be a thing that would occur, that people would probably provide some of these like very standardized auth functions like single key or based off of Stellar accounts or stuff in a library that you can use. But if you want like a stateful system, like Lee, you were talking about aliases, and that's why I keep coming back to this. Like the stateful system is only really useful if your state lives in a centralized place that that people can rely on. Like it would be really annoying for me to have to go and set my alias in every single contract that I use. Like I could, but that just seems really irritating. I think people would much prefer a system where, if that's an option, there is some global contract where that state lives, basically. I guess you could have a really simple contract, just like an aliasing contract, and then you could have library code that uses that. I don't know. There's a lot of options here.
Like aliasing is to me super interesting. Like, is that so? Like, how do we think about that? Like, when you say like, when you make, so this is like the smart wallet type of like situation where the smart wallet is kind of shielding or separating the whatever key you're using at that time from your persistent ID on the network.
I wouldn't necessarily call it like a smart wallet. I mean, it's like kind of tangentially related. I guess it would what I'm really saying is like, I sign using key X, but my public key always stays as Y, and I can change X to X prime or X double prime or X triple prime, but my public key always stays Y.
Yeah, so for context, I think the aliasing came about because we were talking about how do we replicate what exists on Stellar today in the smart world. And what we have today with, like, we often talk about Stellar multisig, but actually the other component of Stellar's multisig that we get is aliasing, because you can have an account identifier and then you can attach other keys to it. And so Stellar accounts provide these two concepts, aliasing and then multisig. And I think, there's been the concern presented that, we shouldn't just implement the multisig that exists on Classic over on Smart, because there's a lot of trade-offs with doing that. But the aliasing alone is like a feature that I think that's worth us exploring. Like, what will that look like? Because it allows people to do things like rotate their keys, or have multiple devices or using the same key, or using the same address. And if I understand correctly, John, you're saying that aliasing capability could actually just be a contract.
Yeah, that's exactly what I'm saying.
Any other questions on CAP 52? I think because this is so fresh, we probably need a bit more time to get into the weeds.
John, could you elaborate a little bit on how you see replay prevention happening? So I see in the cap that there's this announce, that concept exists. Yeah, could you elaborate a little bit with how you see contracts would typically do that?
Yeah, I'm happy to do that. So this whole replay prevention thing gets kind of annoying in this proposal. That's one of like the big downsides of this approach that I pointed out in Cap 50 when I said like why we shouldn't do this. Which is basically like every contract ends up implementing their own replay prevention wherever it's needed. And this means that like things get pretty annoying fast. For example, like on Stellar, you like consider Stellar today, you might like submit a transaction and you have replay prevention on it because of the sequence number, and you also have like a deadline effectively, the max time, and you know that if you get to that point, everything is done. It can't execute or it has already executed. But like if you want that functionality here, you also have to implement the deadlines in your contract and all these other things. And everything just gets kind of annoying fast, basically. Now, again, same kind of thing that I was just talking about. You could actually, because like in this approach, because everything is done by signed messages, you can actually delegate all of this to like some other contract that deals with it. So you can imagine implementing Stellar's time bounds and ledger bounds and all that other stuff in a contract and reusing it if you so wanted, or you can rebuild it in your own contract as well. But basically, there's no generic nonce here. And the cap goes into a little bit of detail about like why you can't use the sequence number. And they're like, my original proposal here actually had an example where the sequence number was like the transaction sequence number was used as a nonce. But it had a couple like kind of annoying details about it, specifically like such a contract is like really vulnerable, or such a design is really vulnerable to what's it called? Confused deputy problems. And if you try to fix the confused deputy problems, then it becomes impossible to use the sequence number as a replay prevention tool. So there's a lot of trade-offs here, basically. Like I can imagine an argument where we just say like, hey, like people should be cognizant of their confused deputy problems, etc. And we make that an option again. I don't know if I would personally feel good about that, because confused deputy problems are like a very difficult foot gun to deal with, I think. Like they're an easy thing to overlook. So I don't know. But basically, yes, every contract is building their own replay prevention or relying on it from somewhere else on chain.
Got it. I think one nice side effect of not exposing the transaction source account and sequence number to the contract is that contracts are getting really set up for that common relayer pattern that we do see in other ecosystems, where people design their contracts so that the message that's getting signed to be used, like the contract call that's getting signed to be used on chain, is independent of the participant who's actually submitting it and paying the fee. And that participant could be like a third party that has, is playing that role of relaying, making sure that the transaction is on network. So in some ways it's nice. It sort of sets up contracts to really work well with that, because if a contract is written to use the source account, you don't get, like, you would have to then modify the contract to make it work with a relayer.
Yeah, definitely. You mentioned this to me like, I don't know, a week ago or something, and that idea really kind of stuck in my head when I was writing this. So I totally agree with you that that's a huge advantage of this design.
I think something that I've heard, I think maybe Graydon like raises a concern is if we encourage people to write their own replaying mechanisms, which I don't think we can actually really get away from. So maybe it's not worth having this conversation. But if we encourage people to write their own replay mechanisms, people may write replay mechanisms that are really inefficient, say as storing data on chain forever type of inefficient. do you think there's anything that we can provide that'll, like maybe some utilities that we can provide in the SDK or even in the host functions that might help people write replay prevention mechanisms that are more efficient, that, use the ledger in a less aggressive way?
I haven't given that too much thought, honestly, but like, I mean, my general kind of perspective on this is, it costs money to use the blockchain, and people will be incentivized to do things that cost less money. So basically, if there's a reason to do a really inefficient replay prevention mechanism, because it makes the rest of your contract much simpler, or maybe it's the only way to even do it, then I think people will do that. But in the absence of that need, I think people will favor the super simple mechanism that's cheap. Whether I can guarantee that, I don't know. And whether we can provide some utilities, I'm not really sure. I mean, like a really simple replay mechanism, like a sequence number, is basically like you have a map, you look it up, you check, you increment. That's it. It can be hard to make it much simpler. I mean, like we could provide some like library functionality that literally does that exact thing. But the thing is, if you have an account that already has per user data, you would probably want to like wrap the nonce in with the other per user data, and then the helper is not actually helpful in that case. So that's kind of the main perspective there. But I have been thinking in general, this is like a bit of an aside, that it would be really helpful if the SDK provided some types, like for example, like there's the SC val map type, which is like a map in the sense of like a conventional map. But I've also been thinking like sometimes it's like you want to look at the data as in like I have a bunch of data stored in different ledger entries, and it'd be cool if there was a map type that did that very easily instead of having to use like the contract put, contract get, etc. in CAP 53. So maybe there's some interplay between that and a replay prevention mechanism that we could learn from.
Yeah, I mean, I think that, yeah, all those things are going to, like, as we develop, like even basic applications, will factor, like this type of basic functionality in some rates, right? That people would just use. I'm not actually too concerned about people having to write it, because we are going to write it. I think for more like maybe like different type of replay prevention, like I think that's kind of the nice thing about this proposal is that I know in the past we discussed like potentially doing very different things, like where you have like those like ephemeral type of things that only work in a specific time period, right? So that you could, in theory, like replay in a specific window, but in some design is actually acceptable. And then you end up with like much simpler client-side code. So, yeah.
Hey, can I ask, dumb question, but you have a function in here called nonce of. How does that work? What does that do?
It's just a contract internal function. I don't know if the comments emphasize that. They don't. It's not a host function. Basically, it just reads the data. It just reads a ledger entry and finds the nonce in that, which would probably just be a single, integer stored in a ledger entry.
Okay, so nonce of in this case is user maintained data associated with an address.
Yeah, exactly. Contract maintained data, I want to say, but yeah.
Okay. In general, I mean, I'm a broken record. I don't want to waste too much time with this, but I am extremely nervous about suggesting that users will learn authentication mechanisms. I think this is just asking for disaster, but I understand that we've been around this like a lot. So I'm
You
probably
don't need to convince me. I mean,
the
I
voice
was
of dissent.
proposing just providing the really, really simple authorization mechanism is the only one.
I would strongly favor that approach. This just feels like it's going to be a disaster. You're going to have people who completely fail to because this code path, if you get it wrong, is game over for everything, and it's so easy to get it almost right, and your tests pass, and you deploy it, and you think everything's fine, and then it's not. So I would love to not have users writing this code, but
Okay, so obviously, I think we need to spend some time evaluating this proposal. In the meantime, we have 10 minutes remaining, and I'd love to hand it over to Siddharth to talk a bit about the changes to the smart contract lifecycle, and potentially any open questions that we need to answer.
Yeah. So the most recent change was a small one about how the contract ID, which is now a hash, is calculated. And you can look at that change. It's pretty simple. Where if it's created from a transaction, you hash the source account, the user provided salt, and if it's a contract created within another contract, you hash the parent contract ID and a salt provided by the contract. So, I mean, if there are any questions there, we can talk about it. But I think the more interesting thing are these two other points I want to bring up. One is mutability, which is do we plan on adding initially the cap right now does not have mutable contracts, but the question is, should we leave that question open for the future, or should we just say contracts will always be immutable? And the second thing is, do we allow contracts to be removed? So the cap has a host function to remove the contract code entry. So I think we can start with the mutability question. Right? If we do allow mutable contracts in the future, a big question was how do we deal with versioning? And I was taking the approach that let the contracts deal with it. So if a contract A calls contract B and contract B is mutable, contract A just trust contracts B's creator. Or right. So I think Graydon had some issues with this. Graydon, do you want to talk about this?
well, I think they're just. I keep coming back to the general sense I have that cross-contract calls are something like dynamic linking, or package dependencies in software in general, right? That smart contracts are software, and this is a general software versioning problem. And in general, software has like natural tensions around versioning that people frequently want to lock to particular versions, but they also frequently want to get the newest latest. And there's a concept of newest latest that is compatible and a concept of newest latest that is not compatible, that is often expressed in major version numbers or separate APIs or separate names for things. And I'm concerned that we are not reproducing any of the infrastructure that would be normal to support points on that natural tension. So I think it is worth trying to provide some of the building blocks that people are going to provide themselves anyway, because it's bad enough to have like versioning. It's worse if there are multiple versions of the versioning system and you have to like opt into different versioning regimes depending on which ecosystem you're adhering your contract to. Like I understand there's this natural tendency in our conversations here to try to push everything to the ecosystem and let the ecosystem figure stuff out, let them develop patterns in the smart contract space that just solve the problem however contract users would like them to. But that is not actually as much of a solution as I think it sounds. That really strongly introduces the possibility of totally incompatible regimes developing in parallel, or inadequate regimes that miss some important aspect of the design because they were cobbled together in a hurry. So I wouldn't mind us spending enough time to be able to provide the basics, which is like, I want to pin to a version. I want to pin to a major version and only get security updates, or I want to follow, any new features and additions that people add, including modifications, upgrades, whatever. I feel like there's got to be a future where those are things that someone's going to provide, and it's our position to potentially furnish them. Maybe it's not, but that's what it feels like to me.
But like at our layer, like is it is it just having a way to have like immutable versus mutable contracts, and like the versioning is metadata basically, and it's up to when you write a contract, to decide how you want to use this metadata?
Okay, when you make a cross-contract call, at the moment, a cross-contract call only identifies a contract ID.
Right. And
So it does not say call this, but give me version 5 or give me version 7 or whatever. Like there's no version information in cross-contract calling right now, which means we're essentially always dynamically linking to either immutable, exactly the same thing, or immutable, whatever the person updated that contract with.
the thing is that, I mean, you have a bunch of things that feel like if we do that at the kind of protocol layer, we're kind of creating those weird things. Like, for example, like if you're talking about different versions, right, of a specific contract, like you have what is like there are a bunch of questions around, like, you have a 1.0, but maybe the 1.1 is actually deployed by somebody else, right? Like it's not even the same author. Like, how do you deal with those type of situations? Like, who do you trust to be 1.1? I don't think we have the notion of of actual like the organization or whatever that is the publisher, right, of a contract.
Yeah, I agree. We don't have any notion about that. I'm advocating for us to come up with a notion rather than saying.
But that notion, like, I think it becomes, I think, in that space, I don't think you can necessarily come up with a one size fits all, because it's not like in like normal, I mean, they say like normal software, right? Like you have a company and they ship their thing, and that's kind of it. Like here, and also like if you depend on a specific version, right? As a my installer basically is going to just cause the OS, right, to grab that version that I depend on. Only in a blockchain type of situation, if that other version, like the cost of keeping that other version around is actually on the on whoever deployed that contract. So if you say like, oh, I want to pin all versions, like everything is always pinned, I think that the implication there would be, well, okay, the publisher has to keep around all versions of their contract, which is kind of weird.
Okay, so could you make a concrete proposal here? You're talking about you would like all contracts to be mutable, mutable, not immutable, but mutable, so you can mutate them. And if I ever want to have a pinned version, I vendor it. Is that what you're saying?
Not necessarily. So I think it's like, yeah, you could have always vendor, of course.
I mean, that's a solution, and I'm okay with that. I think we have to think through the scenario, is what I'm saying. And I think if what we're saying is we're not going to give any thought to the scenarios whatsoever, and then we're going to tell everyone to proxy every single call they make because that's the only place they're going to have any ability to enforce policy, I think we're kind of losing a good chance to shape the system.
I think it's more like, what are like the things that are like support, like that you get with tooling that we can provide, versus things that are actually baked at the protocol layer. Like, I think that if you have a way to say, because you'll also have the other problem, right, of contract discovery on the network, like which contract do I trust, versus the ones that I partially trust versus the one I don't trust, right? There are some that were basically you trust that contract, that even if it was mutable, you trust that they're not going to, or you're actually fine with them modifying it. In other situations, you do want to pin because you have like an actual I mean, maybe it's a stability thing or whatever, right? There you have like other problems there. So some of these data, like the mutability aspect, I think that's actually, that's a property of the contract, so that basically, can I even directly depend on this from my contract, or is it potentially going to change under me? But then you have the different problem, I think, that is kind of like when you do, like with, when you have your manifest files, when you decide that you're going to pin your dependencies, right, in your own program. That decision is something where I think we have to just develop the right tooling. But it's not something that actually the network shouldn't have, I think, an opinion on like like even the schema of how you pin things.
I guess I'm saying that the network has to provide whatever is necessary to support it. So we come up with what we want. We come up with what the network needs to support it, and I'm not seeing that developing in our conversations. We talk about like bad things can happen, and then we throw up our hands and say, obviously, we can't solve it. Like,
no, we have. I think we
let's try to solve this. Is what I'm saying.
I agree.
Let us try to
solve
figure out
it.
what the pattern is, and then figure out what the network needs to actually support it.
Right. I think we need to kind of to solve those problems. What I'm saying is that we don't need to because like the things that I've heard so far, they are in the context of a cap, and in the context of a cap, we are saying this is going to be like we kind of force a specific model at the protocol layer. Oh, and I see a raised hand with that.
I think
Cassandra, I wanted to talk.
I think it still needs to be in a cap. Like it needs to be in the design rationale for this cap. Like if we're saying that we're going to provide this limited set of functionality and you can go and do whatever you want, we still need to provide in the design rationale, this is how we expect it'll be used, this is how we expect it'll solve this problem of versioning. And I think at least I can already see like there are some gaps here. If we say that you're going to do, all contracts are immutable, so with an I, and you're going to do versioning yourself, data migration. How's data migration going to work? Because like right now we have cap 53, and contracts can't access other contracts' data. So how is contract, V1 its data going to be migrated over to V2? And then if we say that, V1 and V2 are going to coexist at the same time, how do contracts do that? That seems rather complex.
Yeah, and especially, and actually, like, in the context of CAP 53, I agree that it's also, you would change your, like, if your ID on the network is your contract, like the contract is your ID type of thing, you don't want to be changing your ID. Like if you upgrade that contract.
We got a request to speak from the audience.
And I don't know how to take them. I don't think I have the rights.
Sandra, question?
Hello, can you hear me?
Yep, we can hear you.
Great, thanks. Appreciate the conversation and glad I was able to hop in. I'm going to keep it short because it's going to be slightly off silo of what you're discussing. I am a week away from dropping a tokenized community with a coin that I'm bringing over from Rally into Solana. And I want to develop on Stellar. And I've looked up online, there's some people that, help you launch. I'm just trying to understand based on what I know with moving forward. I mean, who can I connect with so that I can understand the liquidity and how the Stellar network works and how I can make sure that that same liquidity, I'm probably going to lose it, but how I can transfer over to the Stellar network and really make sure that I look at all aspects of where I'm launching so that I don't have to wrap and do it differently in a month. Do you know what I'm saying?
Yeah, Cassandra, I appreciate the question. This specific conversation is about a very specific topic, technical topic. And you can go to the to one of the other channels, support, for example, ask that question, and I'll be happy to help you there. So thank
Okay,
you.
thank you. I'm just looking for a personal contact. I'm not bringing in the conversation. I can't find anyone, and I've left a couple messages in the chat, but I'm not sure who to talk to. So who is just speaking, and then I'll tag you?
Tomer, just tag me. Thank you so
Oh,
much.
awesome.
Okay, so we're over time, and I think there's some really interesting discussions here that we probably need to continue either on the Jump Cannon dev channel here on Discord or on the mailing list. So I think we should go with that. Thank you all for joining and tuning in, and have a great rest of your day.